Google have just open sourced its algorithm for deep search. Actually, it's more than an algorithm. It's a whole system of prompts with an application made in React. I think it's really important for us, whether you are an entrepreneur or developer, because you can have a glimpse into the brain of Google engineer, one of the most talented developer in the world, to understand how they think when they are building an application. So in this video, we will see first the theory, how they are thinking about the algorithm, what are the building blocks for this application, and then we will go deep dive in the code to understand how does the code works. In Google Deep Search algorithm, there is 4 main building blocks. And actually, it's not an algorithm, it's an agent. It means it's an AI that have several instructions, and with this instruction composed, the AI will be able to take action and even to have its own decision to understand how it will resolve our query. The first thing is for the user to ask a question. Then the LLM will take this question and generate few queries. Here, the task of the LLM will be to generate multiple queries that are really contextual with this question of the user. And what I mean by that is when you ask a question to someone, or in this context, an LLM, there is always multiple angles in which you can decide to answer. Well, here, the task of the LLM is to generate a wide range of query that will match the question of the user and that will target multiple angles of the question. With this list of queries, we could have go by ourselves, make search on Google. But here, we won't do that. It's the LLM that will use tools to make by itself the search related to these queries. With this web search, we receive some search results. And here we go to the third task for the LLM. The main goal here for the LLM is to judge, to assess whether the search have been wide enough, or if we need to go back to the second task and to conduct another wider search. In the other case, if the LLM decide that the search results that we have is good enough to answer the question of the user, then we can go on the fourth task, which is answer generation. Here the LLM task is to take all the web search results and to use it as context to answer finally to the question of the user. One thing that is important to notice, it is that for each task, we have here 4 tasks, we take an independent LLM. So it doesn't mean that we use a different provider, but we create another instance of the LLM. It's important to specify this characteristic because we could have just take the same LLM for each task. But here, and it is better to do it this way, we take an independent LLM for each task. This will allow each LLM to be a kind of expert in its specific task. What I mean by that is that if you reuse the same LLM for each task, you will have a really long context for each new prompt. And it's a problem because for now, the more you have context in your prompt, the more LLM can make mistake. We want to reduce this possible error and to maximize accurate results. So for this, we use an independent LLM for each task with its specific context. Now let's talk about the code. Here we have 2 files that for me are the most important. It is the first, the prompt. We won't read it here together, but you can check them. We have 4 tasks. And so here we have 4 prompts. This prompt will be used in the code and specifically in the graph.py. So the most important part of this file is here at the at the end. It's here that the engineer have built their agent graph. And so we can see here the 4 main components of this graph. So once again, we can see that we first generate query with the question of the user. Then based on these queries, we will do web search. Here, the LLM will use specific tools. And after that, we have the reflection where the LLM will judge whether or not the results are satisfying. And finally, we will answer to the user question with the appropriate context. So each of these tasks, we can call them node, are actually functions that are defined in this file. So the first thing we have to do is to generate queries. So first we'll take an initial search query count, which means the number of query we want to generate. Here then we initialize our LLM. In there we specify that the output will be in a list format. We specify the current date. Here we format our prompt, and for more precision, this variable here is the first prompt there. And finally, we use the LLM with invoke with the appropriate prompt we just created here. For the second function, we will do web search, and it means that the LLM will use a specific tool to conduct this search. So first thing we do here is to format the prompt, and here we specify the LLM that we will use. And you can see that here also we specify a tool, which is Google Search. What you see here now, it's the data and metadata that we have extract thanks to our tool use. So we now have our search results. We can now pass to the reflection task. So I think this task, this node, if you will, is the most important and the most interesting, because it's here that the LLM will really adapt to the situation. So here the LLM will judge the current results and will decide whether or not to continue this web search. The problem that might happen is that we can be stuck in a loop where for every result, the LLM is never satisfied. This is a huge problem because LLM are not free, and it can increase dramatically the amount of money you pay for this LLM. So to be sure to set a limit to this task, we set here a research loop count. This is really important, and it will be used in another function, which is evaluate research. And we will assess if we have reached our maximum research loop. And if so, we will stop the agent to conduct research. So back to our reflection function, we set here a current date. We have our formatted prompt that we can find in the prompt.py file. Here we create another LLM. So to remind you, each LLM for each task are independent, which means we initialize a new LLM for each task. And here we will use the LLM and specify how we want the output to be formatted. So you can see here that we ask the LLM if the results are sufficient. And if we check in the prompt, the LLM have the task to either output true or false. So if insufficient is false, we will conduct new research. And if insufficient is true, we will stop the research and be able to answer the question of the user. Also important to notice, with the research loop count, it means that even if insufficient is set to false by the LLM, well, if the research loop count is superior to max research loops, the research will stop. And finally, the last task, the last function, the last node. Here also we have a parameter. We still take the current date and we format the prompt to send it to the LLM. Here we initialize the LLM and we use it with our prompt. Here we make a little formatting change, but it's not really important. What is important is the results that we have and that we can send to the front end. So now we know how Google have engineered its own deep search algorithm. I think it's really important to have access to this information This way we can really understand how Google engineers think about algorithm and more specifically AI agents. So we have seen the theory part of this AI agent, but we also deep dive into the code to understand really how does this node, this task really work under the hood. I hope you liked this video. If you want to work with me or subscribe to my newsletter, feel free to check the comments.